Hello everyone. I will talk about non-parametric analysis of variance, that is the Kruskal-Wallis test. Non-parametric statistics, also known as distribution-free statistics, may be applicable when the nature of the distributions is unknown and we are not willing to accept the assumptions necessary for the application of the usual statistical procedures. Many of the non-parametric tests are easy to compute and can be used for a quick preliminary approximation of the level of significance. Most non-parametric methods require that the data be continuous and independent. The Kruskal-Wallis test by ranks, Kruskal-Wallis H test, named after William Kruskal and W. Allen Wallis, or one-way Anova on ranks, is a non-parametric method for testing whether the samples originate from the same distribution. It is used for comparing two or more independent samples of equal or different sample sizes. It extends the Mann-Whitney U test, which is used for comparing only two groups. The parametric equivalent of the Kruskal-Wallis test is the one-way analysis of variance, that is, ANOVA. A significant Kruskal-Wallis test indicates that at least one sample stochastically dominates one other sample. The test does not identify where the stochastic dominance occurs or for how many pairs of groups stochastic dominance obtains. Since it is a non-parametric method, the Kruskal-Wallis test does not assume a normal distribution of the residuals, unlike the analogous one-way analysis of variance. If the researcher can make the assumptions of an identically shaped and scaled distribution for all groups except for any difference in medians, then the null hypothesis is that the medians of all groups are equal, and the alternative hypothesis is that at least one population median of the one group is different from the population median of at least one other group. Straight away, we'll go to a problem. A company analyzed the aspirin tablets by three methods. First, they followed the acid-base titration. Next, UV visible spectroscopy for analysis of the same tablets. And method C is the chromatographic technique. Now use the H test to determine at the 0.05 level of significance whether the three methods are equally effective or not. Ordinal data is displayed in the table here. We have three groups and we have different scores for each group. How many samples are in group A? As you can see, there are 6 samples. In group B, there are 7 and in group C, there are 5 only. Is there a difference between groups 1, 2 and 3 using an alpha level of 0.05? We are going to perform a Kruskal-Wallis test on this dataset to see if there is a difference between the three groups. Kruskal-Wallis test has 7 steps. First, we are going to define what our null and alternative hypotheses are. Next, we are going to state our alpha. Then, we are going to calculate our degrees of freedom. Then, we state our decision rule. Then, we actually calculate the test statistic. And finally, we state our results and our conclusion. So, let's start with step 1. Defining the null and alternative hypothesis for a Kruskal-Wallis test. Our null hypothesis H0 is that there is no difference between the methods that we are comparing. Our alternative hypothesis H1 is that there is a difference between the methods that we are comparing. Step 2 is to state the alpha level. That's easy because I already said use an alpha level of 0.05. Next, we are going to calculate our degrees of freedom. Degrees of freedom are equal to k minus 1, where k is the number of groups you have. So in this case, our degrees of freedom is equal to 3 minus 1, that is 2. Next, based on that information, we state our decision rule. We go to the chi-square table, which is what we use for the Kruskal-Wallis test. We have an alpha level of 0.05 and 2 degrees of freedom. Using that information, we can find our critical value. Here, our critical value is 5.99147. So, if the chi-square value that we calculate is greater than 5.99, we can reject the null hypothesis and say that there is a difference somewhere between the three groups. If chi-square is not greater than 5.99, then we will not reject the null hypothesis. Now let's actually calculate a test statistic. Here we have our data, and what we want to do for a Kruskal-Wallis test is to organize our scores by rank. So basically, we want to organize them from smallest to largest. Here we have three groups and a total of 18 scores. We are going to rank those 18 scores so we can calculate the chi-square statistic for a Kruskal-Wallis test. Here, we just take in the original scores and rank them. For example, our smallest score is 60, so we rank it 1, and our largest score is 93, so we rank it 18. Now the table is changed to reflect that we're no longer working with the original data. We're working with our ranks because remember, our original data is ordinal. So now we can calculate our test statistic. We're going to call it H, but just basically think of it as a chi-square value, and here we have our equation for calculating. It's 12 divided by n times n plus 1 times all the sum squared divided by n minus 3 times n plus 1. That sounds kind of confusing, but I'll show you right now how we actually get those numbers. So first, R is our sum. For example, the sum of group 1 is 61, the sum of group 2 is 62, and sum of group 3 is 48. And N is just the sample sizes, which is 6 for group 1, 7 for group 2, and 5 for group 3. Capital N reflects the total sample size, which is 18. Now we just plug all those values into the equation to find our H value, which comes out to be 0.197. So now we can move on to our results. Remember, our decision rule was if our chi-square value is greater than 5.99, we were going to reject the null hypothesis. In this case, our value is 0.197. Because it's not greater than 5.99, we do not reject the null hypothesis. Now we state our conclusion. Basically, what that means is that there is no significant difference among the three groups that we compared in this Kruskal-Wallis test. Now this test is appropriate for use under the following circumstances. When we have three or more conditions that we want to compare and each condition is performed via a different group of participants and the data do not meet the requirements for a parametric test. That's all for this presentation. Here are some questions for you. Thank you.